Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to learn how to solve a system of equations using matrices. So why don't we go ahead and get started. So what we're going to do here is first I'm going to explain the concept behind matrices. So let me go ahead and write a little equation for you here. I have 2x plus y equals 7, and then below that I have x minus 2y equals 6. Now, we've learned how to solve this with substitution, elimination, and even graphing if you so desire. But there's another approach that can be used in this matrix, using a matrix, or matrices if you will. And so here's what's happening when you do a matrix. What happens is that you are able to remove the variables inside the matrix and just focus on the numbers. And there's many different things you can do with the rows. You can flip them, you can multiply them, you can divide them, you can add to them, whatever you want. And your goal is to eventually have something called row echelon, which is what I will explain in a moment. Now, with the matrix, basically, they don't show you this, but this is kind of what's happening. You have the x as one column, the y as one column, and then you have the stuff on the equal sign, the furthest to the right. So 2x will become just 2 because the x is kind of up here above. And then the x here will be 1. And then right here we'll have the plus y, so this will be just a 1. Here we have minus 2, so that'll be a negative 2. And then we still have our 7 and our 6. So we have the same three numbers in each equation here. The only thing that is missing is that we've removed the x and the y, and we just have the stuff inside the brackets, if you will, here inside the matrix. And so our ultimate goal here is to get something like this. You want it to be, let me use a slightly different color here for you. You want it to be something like this. So you might have a 1 here, a 1 here, maybe still have the 7, I guess is possible, and then a 0, and then a 1 here, and the 6. And so what is happening is that you want something called row echelon. I've already told you about this, and that is where the diagonal has only ones, and to the left of the diagonal, below it, you have a 0. And what is essentially happening here is that, 1 is basically y, and then you still have your equal sign here, equals 6, because the x has been eliminated. And so what has happened here is that by having the ones in the diagonal and having 0 below the diagonal to the left, you have eliminated those other variables, and now I can plug in my y here into my original equation to solve it. That's what we're going to try to do in this video. So let's get started. I'm going to rewrite my equation here, and then we're going to try to solve it using matrices here. So 2x plus y equals 7. And then below that I have x minus 2y equals 6. So let me go ahead and set up my matrices. You've seen these numbers before. 2, 1, 7. 1 minus 2, 6. Again, all that's coming from right here. 2 rows because there's 2 equations. Now, the first thing that I want to do, and let me see if I can make this very clear. I'm going to flip the rows. This bottom row I'm going to put on top, and the top row I'm going to put on the bottom. The reason for that is that I will now have this 1 in the upper left hand corner, and I'm beginning the process of getting my row echelon. So if I do this, I haven't done any calculations yet, just flipped. And so I have this 2, 1, 7. It's the same set of 3 numbers, but I just flipped the order. Again, right now I'm getting a step closer to achieving my goal by having this 1 in the upper left hand corner, if you will. Now, the next thing that I want to do is I want to find a way to deal with this 2. So this 2 is I need to find a way to make it a 0. And this is what I'm going to do. Please listen carefully. I'm going to multiply row 1 by negative 2, and then I'm going to add row 1 to row 2. That's what I'm going to do. Now, again, this is a temporary calculation to the first row. I'm not going to change the numbers in the first row. I'm just going to take those numbers and use them to manipulate the second row. Now, watch carefully. 1 times negative 2 is negative 2. Negative 2 times negative 2 is positive 4. And Negative 2 times 6 is negative 12. That's what we have here. Now, I'm going to go up here, draw new matrices, and watch what happens here. Negative 2, let me change the color here. Let me change that. Negative 2 plus 2, adding these two together, is going to be a 0. Oh, let me make that a little bit better for you. 0. 4 plus 1 is going to be a 5. And negative 12 plus 7 is going to be negative 5, like so. And then across the top, I still have my 1, my negative 2, and my 6. That's what I have. And so we're one step closer. Not only now do I have my 1 in the upper left-hand corner right here, I also have my 0 down here. So now the next step is going to be to deal with this 5 here. I must find a way to make this 5 a 1. So I'm going to move to the next slide and make a little bit more space for myself. If you don't mind, please be patient. So I have 1, 0. I know I had a 5. And what else did I have here? Negative 5. And then I had a negative 2 and a 6. Let me check that, make sure it's clear. 1, negative 2, 6. 1, negative 2, 6. 0, 5, negative 5. 0, 5, negative 5. Okay, now for the next thing. In order to make this guy a 1 here, I have to multiply him by the reciprocal. This is something you should have learned earlier in mathematics. And so when I do that, I'm going to essentially multiply him by, 1 over 5. So what's going to happen here is I'm going to take row number 2 and I'm going to multiply it by 1/5. When this happens, I don't touch the first row, just the second row. This is what I get. I get 1, negative 2, 6. I get 0. I now have a 1 and I now have a negative 1, like so. And now you can see that we have clearly achieved row echelon. I have my 1s in the diagonal here and I have my 0 right here. So here are the equations that we have. We have x minus 2y equals 6. And the second one we have 0 basically plus y equals negative 1. That's what we have. So now we have to do some simplification here. So this is what we do now. We already know that y equals negative 1. That's right here in this equation right here. So what we're going to do now is we're going to take our value for negative or for y and we're going to plug it into our equation right here. So this is what we get. Let's see here. Okay, so x minus 2 times negative 1 equals 6. So x minus 2 times negative 1, that's going to be x plus 2 equals 6. Minus 2, and we know that x equals 4. That's what we know. And so we are done. If you plug these back into the original equation, you will see that this will give us our answer. So going back here, so let's see here. X is 4, y is negative 1. So x is 4. Y is negative 1. Here we go. I'm going to plug this into the original equation. 2 times 4 plus negative 1 equals 7. Now again, 2 times 4 is 8. Minus 1 equals 7. Hey, congratulations. First one works. Now x here for the second equation. This is the second one right here. So let's see here. 4 minus 2. We've already solved this one. Minus 2 times negative 1 equals 6. So negative 2 times negative 1 is 2, positive 2. So 4 plus 2 equals 6. And voila, there we have it. We have solved a system of equations using a matrix. And so this is a really great way, another way to think about how to do this. Again, which system works best for you is really a matter that can be argued about a great deal. But in this video, what we did is that we took a basic two-variable system of equations and we used a matrix to solve it. And so with the matrix, you strip the variables away and you just have the numbers inside the matrix. And by understanding what belongs in which column, you know what that column represents in terms of the variable that is dealing with. And so when you have this system, this matrix, you are able to flip the order of the rows. You can multiply or divide or do whatever you want to the rows. And your ultimate goal is to get something that we call row echelon, which is essentially where you have the 1 on the diagonal and you have zeros to the bottom left of the actual rows of 1 or diagonal of 1s. And so once you do that, once you get row echelon like we see right here, and you have the zeros there, basically you have eliminated any variable that has a 0, and then you take the remaining value and you plug it into your original equations to solve for the variable that was canceled out or eliminated, if you will. And so it's a very practical way to deal with this complex system of trying to do algebraic methods. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for listening.